So straight lines, the concept of straight line is very fundamental to geometry, and how to, you know, how to find the equations of straight lines. So straight line is a form of a locus where points are connected one with another. And we know what is the concept of a line from basic geometry. So how to represent the straight lines in coordinate systems? That is our discussion. Let's say this coordinate system, X and Y. This particular straight line, how it will be represented by? Because we have done locus of curves. So the straight line should also be represented in terms of some equation. So before we begin with the concept of inclination of a line. So inclination of a line. It is the angle made by the line with the positive x-axis. With the positive x-axis measured in anti-clockwise sense as positive. So the inclination here from the positive x-axis, we find the angle theta. So this gives the inclination. Theta is the inclination. And interestingly, the inclination we represent by theta, and values of inclination. Can you say what is the minimum value and the maximum value of inclination? Any of you? What is the minimum value of inclination and the maximum value of inclination? Yes. No one is answering. The minimum value of theta will be 0 when the straight line is parallel. So let us say the straight line is parallel to x-axis or along the x-axis. The inclination, the angle made by the line with the positive x-axis will be 0. Then this is an acute angle. And then we can have inclination of another line which makes obtuse angle with the positive x-axis. So this is theta. So here inclination is 0, inclination is acute, inclination is obtuse. So now, can you tell me what will be the values of theta? How will the theta vary? Theta can take values from 0 to 2. Tell me.
Infinite.
Go ahead. Yes. Don't be afraid of mistakes.
90.
Hmm?
90.
No, I didn't hear you.
90.
Just a second. There is some issue with the. No, it is not 90. It is definitely not 90. Then it is 180. 90 obtuse angles are there. No? It can go up to 180 degrees, but not equal to 180 degrees, because if you take 180 degrees and 0 degrees are one and the same. All right. Maybe I should show you with GeoGebra. 1 second. You will understand this. Let's say we plot an input slider. I'll call it as M. Hmm. Okay, M is a number. Okay, now I plot Y equal to MX. So this is the line. This is the slider. It is sliding these values. Okay. Okay. It is not able to show it. It is so. Wait. Let us start now. Oh, it's huge values. That's why I'll reduce the values and then see. Oh, increment. You are seeing how the angle is changing. Now I'll plot the angle also. Just a second. I'll stop this. I'll plot an angle. Now, how okay. Yes, the way it went, just a second. Okay, beta is an angle, doesn't matter. So, now you see how it varies. Now, when m is 0, beta is 0. Now, when I start, beta is acute, then beta is still acute. Beta goes close to 90 degrees. If it goes to 90 degrees, this m value will go to infinity. So we are not going that, we are going up to 10. So now I will increase this. Now after that, now you see what happens. Again, it's coming back. Now I'll just help you with this. Now when m is 0, here, slope is 0, theta is 0. At the same time, here, if you track the angle, this is x and this is y. Now let us take a line which is along the x-axis. Now inclination with the positive x-axis is either 0 or it can be 180? Because this straight line is not having a specific direction. Either we go this way or this way. It is a straight line. It is not like an arrow. So the angle that is 180 is same as 180 degrees is same as or equivalent to 0 degrees. Understand? Therefore, this inclination after 180, let's say you go further, you cross 180. So 180 plus 30, let's say this is 210. Let us say this particular angle, this is 180. And this particular angle is say 220. Now this 220 with respect to the positive x axis is 220. This is same as this 220 minus 180, that is 40 degrees. So if the line crosses 180 degrees with respect to x-axis, that means the other portion of the line will have an acute angle with the x-axis. That is the reason why our inclination, the basic value of inclination will always be between 0 and 180. So inclination of a line with the x-axis always lies between 0 degrees. It can be equal to 0, but it is it is not equal to 180 because 180 will be same as 0. Of course, we have, angles repeat themselves, but from straight line point of view, not the trigonometry point of view, but the straight line point of view, we just take inclination as 0 to 180. Next is the important concept of slope of a straight line. Now, slope of a straight line is defined as the tangent of the inclination of the line. So it is denoted by M. So M is tan theta. So slope M is tan theta. And it doesn't have any dimension. It is a dimensionless quantity. Now slope is also called as gradient of the line. Gradient of a line. So now how does the slope look? Now we found the inclinations in the previous section. Now we'll look at the various slopes of different lines. Let us take first x, y, the same coordinate plane, but 3, 4 different examples I'm taking. So that's why I'm writing this. First thing, now slope of a horizontal line. This is example 1. So for a horizontal line, inclination is what? Theta is 0 degrees. Slope m is tan theta. Tan of 0 degrees is 0. Tan of 0 degrees is 0. So tan 0 is 0. Okay. Next, look at an acute angle. Let us say acute angles. Let us say this is 30 degrees. Then let us have another line which is of 45 degrees angle. Okay. So these are acute inclinations, right? Inclined lines with positive slope. So this horizontal line, the slope is 0. Now when theta lies between 0 and 90, so inclination is between 0 and 90, then tan theta m equal to tan theta, it is in the first quadrant. If we know trigonometry, the first quadrant values of all the ratios, sine, cos, tan, everything will be positive. So the slope will be positive. So in fact, for this particular line, m is tan 30, and tan 30 degrees is 1 upon root 3. And for this line, m is tan 45, and tan 45 is 1. Okay. This is the value of the slope. Again, I'll explain the concept of what slope is. Now, when theta is acute, that means this is positive slope. This is 0 slope. This is 0 slope case. This is positive slope case. Then next, when theta is 90, slope is undefined or infinite slope. Vertical line. For a vertical line, the inclination, the value of the inclination is 90 degrees. Now, tan of 90, tan of 90 degrees is not defined. Theta is not defined for this. We write infinity, that is not correct. Actually, it is undefined. It is, so it is like 1 upon 0 form. So in straight line, we mark this as infinity, but infinity, this quantity is not defined. However, you can see that as you go closer and closer, the the more the inclination goes closer to 90, like I'll just show the values of tan. Let us use a calculator. A scientific calculator here, trigonometric functions. So tan of 45, okay, 45 tan. Tan 45 is 1, okay? Now 30, tan 30 is 0.577, that is 1 upon root 3. Now let us look at tan 60. 60 tan is 1.7320. It is an irrational number under root 3. Under root 3 is tan 60. So inclination is 60, slope is 1.732. Next, inclination, as I keep increasing the inclination, I go to 80. See what happens to the trigonometric value, 5.67, 80 degrees. Then it rises very quickly when I go to 85 degrees. Tan value goes to 11. At 85, it is 11. Okay. At 80, it was 5. Just 6 jump. Now at 89, it is 57. All right. At 89, it is 57. At 89.5, 114. That means the value is increasing very now. Tan. Now I'll do 89.99. 57,000. Sorry, 5,729. Tan value 89.999999. 57. This is in thousands, 10,000 lakh crore, you know, or more than that. So, or so it is like 5,729 crore, 57 lakhs, 79,513. So it is, number is going very high as we go close to 90. At 90, invalid input. Tan 90 is not defined. That means your slope value is going from 0. As the line changes, slope value goes from 0 to infinity. Okay. Here, slope varies from 0 here, and it goes to infinity. All right. In this particular range here that we have seen in the graph. Okay. Now let us see negative inclinations. I hope you're understanding what I'm teaching.
Yes, sir.
How theta is slope is tan theta. Now let us look at the negative inclinations. Theta is greater than 90. Theta is greater than 90 degrees, but less than 180 degrees. Okay. So now tan theta will, now they'll be different. Some lines will have inclination close to let's say this is an inclination with respect to the x-axis. Let this particular inclination be 90 plus 10 degrees, 100 degrees. This is say 135. And one more, we can plot one more line with almost flat like this. Here, the inclination we measure, let's say it is 180 minus 10, 170 degrees. Now let us look at what will be the tan values for these. Tan value for these. For the first one, theta is equal to 100 degrees. M is tan theta. So tan of 100, let us look. So tan of 100 is minus 5.671. Minus 5.671. It is negative. Next, let us look at tan of 135 here. So 135 tan minus 1. So here theta is 135 degrees and tan theta M, which is tan theta, is minus 1. And then this one 170 tan. It is very small number. Theta is 170. This minus 1.176. Okay. So tan value. Now, if I go close to 180, see what happens. So 179.95, let's say, close to 180. It is going to 0, 10 to the power minus 4. So 0.000872. It is going close to 0. All right. It will go close to 0 because it is becoming a horizontal line. When it becomes a horizontal line, slope becomes 0. However, throughout here, the slope values you see are negative. At 100, it is minus 5. Suppose it is just above 90. Let's say at 91 tan. It is 57.29 with a minus sign, minus 57. Now I do 90.001, just above 90. It is like 57,000 minus 57,000 to 95. So the slopes of when the line is inclined like this, the slope value is close to infinity, minus infinity. Slope is close to minus infinity. And then the slope, as the inclination changes, the slope goes to 0. So these are cases of negative slopes. These were the case of positive slopes. This is infinite slope, zero slope, positive slope, infinite slope, and negative slopes. So a negative slope is the inclination is greater than 90. Theta is greater than 90 but less than 180. Okay. Now what does this represent? The slope or the gradient? And now this was just the numerical understanding of how the slopes change from positive value, 0, positive, and infinity, and then again minus infinity to 0. Slope changes from minus infinity to 0. Okay. Now there's an interesting understanding. Now if you look at graph of tan x, you will understand this much better. This is the graph of tan x. Yeah. Values of tan x, or I put this as tan theta. Does make a difference. Okay, tan theta. Now theta, when it lies, see how the value of tan theta. Tan theta value is on y-axis. Theta is on the x-axis. When theta lies between 0 and pi by 2, tan values are positive. Tan 45 will be 1. Pi by 2 is 90, right? And tan close to 90, tan goes to infinity. This is the graph. At pi by 2, the graph itself is not defined at 90 degrees. Tan value is not defined. Right after 90, tan value is minus infinity. Okay, just after 90, say 90.00001, it will be minus infinity. Then the value keeps increasing, but throughout you see in this region from 90 to 180, tan values are negative. They lie below the y-axis. So they are negative. So that is why, remember, the slope, how it changes, because slope is related to tan. From 0, the slope keeps on increasing to infinity. Slope here starts from 0. And by the time theta comes to 90, the slope becomes infinity. Okay. This much is clear. But now, after 90, when the inclination changes from 90, the slope varies from minus infinity to 0. When theta is going like this, here the slope at this point will be minus infinity. At this point, it will be 0. Throughout the values will be negative. So 0 to infinity, minus infinity to 0. Okay. I will show it in a different figure. Hope you understand. I'm spending a lot of time on this. Slopes. So M ranges from 0 to infinity. Here, in this positive, when theta. It's depend on theta, right? M is tan theta. Now, for this region, like this, if I go, now M ranges from minus infinity to 0. There's also theta, and M is tan theta. So we get M ranges from minus infinity to 0, not theta. Okay. So this is all about slopes. Now, why is it called as a gradient? Okay, now look at this. What is meant by a positive slope and a negative slope? Or positive slope or positive gradient? And we have a negative slope or a negative gradient. How should we understand this? So a positive slope means the inclination with the x-axis, the positive direction of x-axis is acute. So this is theta is acute. So it is a positive slope, positive gradient. It means that the positive gradient means this. When we move in the positive direction of x-axis, the straight line values, the values, if you're the point on straight line, let's say assume a locus, a variable point, it is moving. So when the point is moving from left to right across the x-axis, so I am moving from left to right. In with respect to the x-axis, I'm moving from left to right. But what is happening? My point is moving upwards in the positive y direction. This is called as a positive gradient. As I move from left to right in the x direction, y varies from bottom to top. It is going, y values are increasing from left to right. So look at this variable point M and just imagine that you're moving in this variable along this variable point M. This M is moving and you are sitting on this point M and you're moving. So when you're moving from left to right, you're also going upward. This is called as the upward gradient or the positive gradient. So when x values are increasing, the y values are also increasing. So that is called as the positive gradient. X increases, y also increases. So this is meant by positive gradient or positive slope. Now, what do you mean by a negative gradient? A negative gradient like this, you have an obtuse inclination. Again, you take a point M on the line, and you're moving in the positive direction of x. Always we move in the positive direction of x. When we move in the positive direction of x, that means m is moving from left to right along this line. What is happening to the values of y? The values of y are decreasing. Correct? X increases and y decreases. This is negative gradient. Positive gradient, negative gradient. So positive slope, negative slope means this. So when I'm moving from left to right, I'm going downwards. So that is the negative slope. When I'm moving from left to right, I'm going upwards. That is the positive slope. So going uphill is positive gradient. Going downhill is negative gradient. So that's the way to understand gradients or slopes. So we covered quite a bit in depth of slope. I hope you are thorough with this concept. You don't make any mistake. Now, importantly, now if two lines, very important point, important note. If two lines are perpendicular, that means the angle between the two lines is 90 degrees. Right. Let's say this is the x-axis. This is the x-axis. Now, this angle is theta 1, which is acute. This angle is theta 2, which is obtuse. But if you see, so this angle is theta 2, corresponding angles. And this angle is theta 1. But the difference of the two angles is 90 degrees, which means theta 2 minus theta 1 is 90 degrees. If that is the case, what happens? Let's say this is slope m1. So m1 is tan theta 1. m2 is tan theta 2. Okay. So now we see theta 2 minus theta 1 is 90 degrees. So we can write theta 2 as 90 plus theta 1. And from trigonometry, you may know the basic trigonometry. If you don't, we will soon learn this. You must have learned this in high school. Tan of theta 2 is tan of 90 plus theta 1, which will be minus cot theta 1, which is minus 1 upon tan theta 1. So what we get is m1 into m2. This is a very important result throughout we'll be using in coordinate geometry, is tan theta 1 into tan theta 2, which is tan theta 1 times minus 1 upon tan theta 1. Because if theta 2 and theta 1 vary by 90 degrees, tan theta 2 is minus of 1 upon tan theta 1, which is equal to minus 1. So here we get a very important result. For perpendicular lines, the product of the slopes, their slopes, is -1. The product of the slopes of two perpendicular lines is -1. Okay, M1, M2 equal to -1. Now, how do we find the slope of a line joining 2 points? With this, we'll end for today. This was slope based on inclination, slope of a straight line. So far we did based on inclination. Now next is slope of a line joining 2 points. Say A, x1 comma y1, and B, x2 comma y2. This is given by M. Slope is given by y2 minus y1 upon x2 minus x1, or take minus, multiply numerator and denominator with a negative sign, or we get y1 minus y2 upon x1 minus x2. The order we have to retain the same in the numerator and the denominator, either y2 minus y1 by x2 minus x1, or y1 minus y2 by x1 minus x2. So let us say there so let us say that this is the line. The 2 points here, A, x1 comma y1, and B, x2 comma y2. Okay. This point is x1, this point is x2, this coordinate, this ordinate is y1, and this ordinate is y2. Okay. I'll not draw it here because it will handle. Now, what is this difference now? This length here is, as you can see, x2 minus x1. From origin to here, it is x2. From origin to here, it is x1 distance. So this distance will be x2 minus x1. Similarly, what will be this one? This distance will be y2 minus y1. Okay. Now let's look at, this is the inclination of the line. Now this line is parallel to this line. So these two are corresponding angles. So this will also be the inclination, theta. All right, this will also be theta. So by definition, tan theta, slope, tan of the inclination, which is the opposite side in this particular triangle, A, B, and maybe we can call this point as C. So in this triangle ABC, tan theta is opposite side BC by adjacent side AC. So opposite side is y2 minus y1. Adjacent side is x2 minus x1. Therefore, M is y2 minus y1 by x2 minus x1. This is this law. All right, we stop here for today. You can review this very important notes.